was paralyzed by fear when they heard a mighty multitude was quickly drawing near. But as they prayed for deliverance, the victory would begin. For when we call upon the Lord, we summon all of heaven. Pray on, for you are who the Lord is looking for. Pray on, for this will tear those mighty strongholds down. Stay on your knees, for this is where the battle is won. Very soon you'll win the victory. Pray on. When Daniel faced the lions for worshiping the Lord, it seemed there was no hope at all for what would be in store. But when we stand on holy ground, our smallest prayer is heard. Instead of on our circumstance, our eyes are on the Lord. Pray on, for you are who the Lord is looking for. Pray on, for this will tear those mighty strongholds down. Stay on your knees, for this is where the battle is won. Very soon you'll win the victory. Pray on. When your questions go unanswered and your prayers may seem in vain, they don't seem to make a difference. They don't seem to make a change. Just rest assured God knows your needs, and He hears each time you pray. Your prayers are reaching heaven, and the answer's on the way. Pray on, for you are who the Lord is looking for. Pray on, tear the mighty strongholds down. Stay on your knees, for this is where the battle is won. There's no better place for you to be than seeking the Father prayerfully. Very soon you'll win the victory. Pray on. Pray on.
What a beautiful inspirational song. I hope you had enjoyed it to the maximum. So, as I said before, now we're going to get into our session featuring vectors. Of course, as I said to you before, if you're the only one watching this production today or this live session this evening, I ask that you will share this link with a friend or family, that they too will benefit from this awesome session. Of course, you may interact with me using the live chat. Of course, if you have not yet subscribed, please subscribe now, because the next time I come around, you'll have to subscribe before you can be able to interact with me. So, without any further ado, I'm going to get straight into our live session, starting with a review on vectors. Are you ready? Are you ready? If you're ready, say ready. Say ready in the chat if you're ready. Let's go. All right, so we're going to do our review now on vectors. Now, first, we're going to start off with the coordinates, right? And one of the things you should be able to do is to read and plot points in a graph. So here we have a grid, right? So we have a grid right here that we're going to be using now to start our review so that, of course, you can have uh, an understanding of what we're doing and why we're doing what we're doing. So without any further ado, let me continue with this. Now, for those who may not know, this is called a Cartesian plane, just one of the four quadrants of a Cartesian plane. So now we're going to plot some points here first, but let me write the coordinates so that you can know exactly what we're doing. So this is going to be point A, matter of fact, yeah, let's call it point A. And of course, we will be plotting the point 3, well, 3, let that be 3, 5. Good. So we're plotting the point 3, 5. Now, the first numeral or digit in brackets must be read from the x-axis. And what is the x-axis? The x-axis is the horizontal line that runs across the Cartesian plane. And the second number is on our y-axis that runs up the Cartesian plane, which is the y-axis. So here we have the x-axis and we have the y-axis going up. All right, so let's plot our first point. All right, so we look for 3 here on the x-axis, and we go all the way up to reach 5 on the y-axis. So here is our first point on the graph, right here. Good. Now, we can call that point, of course, the letter A. So that's our coordinate, A. Hope you understand that. Then now we're going to plot another point on our graph. Let's name that point over here B. And that point will be, say, 7, 8. Right. So once again, the first digits or the first coordinate are the x, called the x coordinate, and you'll find it on the x-axis right here. The second digit, which is 8, it's called the y coordinate, and you'll find it on the vertical line, which is the y-axis. So let's go ahead and plot the point B. So point B, so we got 7 right here, our x-axis going all the way up till we get to the number 8 on the y-axis. And then we plot our point. And that, of course, is point B. So now we have plot both points. Now, when we speak of vectors, and there are some particular vectors that you need to know about. And commonly, let me move these things down. Now, commonly, you'll have the following vectors. What we call a position vector. Position vectors. And of course, we have also displacement vectors. Now, in this session, we're going to be looking at just briefly touching on some of these things, different type of questions that can be asked as it relates to vectors. So are the position vectors, and we'll be focusing on the displacement vectors as well. And of course, we'll be looking at the magnitude of a vector. And finally, we'll also be looking at the direction of a vector. All right, so 4 things we'll be looking at in this session this evening. And after this, we'll look at 1 or 2 past paper questions. We'll be looking at, of course, the 2022 exam past paper question. And of course, if there's time allowed, we'll be looking at the June 2019 exam question as well. Just want to remind you once again that if you're the first time viewing us live on our YouTube channel, we ask that you let us know who you are, where you're from, and of course, if you have a friend or family who is doing exams in next year, whether it be January or later down in June 2023, God's willing, we ask that you share this channel with your friend or family. If it's the first time viewing, pray that you click on the subscribe button if you liked this session today or this evening. All right, so let's go to first look at vectors. Now, we're going to look at the term position vectors. Now, in a vector, you will have 2 points. You have the starting point and you have the ending point. You have a starting point and you have the ending point. Now, for position vectors, our starting point is always at the point of origin. Now, that point of origin will begin with the letter O. And if we're going to write or state the position vector OA, it means then our starting point will be the point of origin, which is right here. 0, 0, right here. Good. And then, of course, we're going to count. Note I said what? Count. We're going to count the steps first along the x-axis, then up along the y-axis. And then we'll see what our vector is. Right. So let us do it. So we're going to move. We're going to move from here. We'll go 1, 2. Well, let me say, let's use our pencil point. So we're going to count again. So we started from a point of origin. So we count 1, 2, and 3. We stop here because we're going towards point A. So we move 3 places on the x-axis. So we're going to go up now. 1, 2, 3, 4, and 5. 5 places up on the y-axis. Now that will give us our position vector. So we count on the graph to get the first position vector. Now, so I'm going to write that in column form or matrix form. And so the first number, which is 3 times along the x-axis, moving up from here to here. And then we moved 5 times up. 1, 2, 3, 4, 5. So this is how you write the position vector. Good. So here we have it. So this is position vector OA. Now we use normally a straight line to represent our vector. So this is vector OA. That's vector OA right there. Good. So that's vector OA right there. Then now we are going to know, well, you could I'll pause a bit and have you determine the position vector for OB. Let's determine the position vector for OB. So I'm giving you a chance to determine the position vector for OB. All right. I take it that you know, by now you'd have done that for yourself. So I am going to now demonstrate and watch me carefully how we determine the position vector for OE. Are you ready? Let's look at it. So first we're going to count. So I count from the origin again for OB. So 1, 2, 3, 4, 5, 6, 7. Why we stop at 7? Because we're going up to B. So on the x-axis, we counted 7 on the x-axis. And we're going to go up the y-axis now. 1, 2, 3, 4, 5, 6, 7, 8. So on the y-axis, it's 8. All right, I don't think that looks good, so let me erase it and try again to write it. That's even better, isn't it? So our position vector OB is 7, 8. Now, in the exam, you can be given the coordinates and you're being asked to write the position vectors in the form A over B or in the form X over Y. So this is the form that they are giving you. So all you need to do, you can, if you don't quite understand, you could just draw up a little Cartesian plane, plot the points, and you remember exactly what I did. You get your right answer. So let me now draw our vector OB. So this is our vector OB now. So now we have both our vectors illustrated on the Cartesian plane. All right, now, so we have vector OA and we have vector OB. I hope you understood that. Hope that one was clear to you. All right. So I'm just asking that you share the link to this live session with your friends and your family. All right. Hope you follow the instructions. Are you? All right. So we have just looked at position vectors, and please note that all position vectors begins with the letter O. All right, there you know, that's a position vector. Now we're going to go to our next topic, which is the displacement vectors. Now, make note of this. Make note of this. And what is that? In order to have a position vector, you need to have two, sorry, my mistake. In order to have a displacement vector, you need to have two position vectors. And when we get to the past paper questions, we'll see a much bigger picture of why that is so and how is that information useful. Now, I'm going to look at the displacement vector. So now we're going to clear up these two. We're going to go to our displacement vector. Now, what vector are we talking about? Vector AB. So we're going to go to vector AB. And that means we're moving from the point A to the point B. That's the direction. So let's remove this from here. So we're now going to go to vector AB using the graph. Now, what is vector AB? And I'll pause right here to see what you will do. It's always good to try for yourself something and see what, if you understand or if you're not understanding. So I'm going to pause for a bit and give you an opportunity to determine what is vector AB. Let's see if you're paying attention. Go ahead, try. All right, I am back. Did you try for yourself? I hope you did. All right, so I'm back. Now, using the graph, of course, I'm going to determine what is vector AB. Now, let's go. So 1, 2, 3, 4. So 4 on the x-axis. And then we're going to go up. 1, 2, 3 on the y-axis. That is vector AB. Simple, using the graph. So in the exam, you can draw a graph or sketch a graph, use a ruler, and draw a decent graph. Using a one, please note that this is a 1 centimeter parts. This is each distance between each number is 1 centimeter. So when you're using a ruler to draw up your graph on your paper, just to get a correct answer, you can do this. So the graph is an easy way of determining the vectors, the position vectors that you're asked to determine. In one of our sessions, I'll show you a trick that makes some of those vector questions that you think is hard to do made easy. All right. Now, so we have looked at the position vector. We have looked at the displacement vector. Now we're going to look at the magnitude of a vector, the direction of a vector. We're doing all 4 of these using the graph. Then I will move on to how can we determine these vectors, the displacement vector, the magnitude of the vector, without using the graph. So let's go. All right. Now, the magnitude of the vector is really the length of the line that represents the vector. So I can use my ruler here. And then I'm going to measure the length of that line. All right. Now, just to ensure that you're seeing it clearly, I'm going to expand it so you can see. I hope that you have a good viewing. Now you can see that I'm using a ruler as a centimeter ruler. And of course, you can evidently see that the length of that vector is 5 units or 5 centimeters. That's the magnitude of the vector. So it could be 5 units or 5 centimeters. All right. That's the length of the vector. Now, so we use a ruler to find the length of the vector. And I want you to make note of that the magnitude of this vector, vector AB, is in fact 5 centimeters or 5 units. Make note of that. All right? Make note of that. All right. So I'm using the graph once again to show you how to find the magnitude of the vector. And of course, I'm going to show you how to use the protractor now in finding the direction of the vector. Let's carry it back to a better size. All right, so let's remove this. All right, now to find the direction of the vector now, using the graph and our protractor. Now, how is this done? All right, let's see. Now, please note that the direction of the vector is communicated or expressed in degrees, and it is formed as an angle between the horizontal line x-axis and the vector itself. What am I talking about? All right, let's draw a little line. Right. So we're going to draw a line here, as you can see, right here. So this is a horizontal line in green, and the angle is being formed between the vector and this horizontal line. And that will give you the direction of the vector. So I want to place the center of my protractor on the point and ensure that the zero line is in line with the horizontal line. So let us now maximize that so we can read off the angle properly. Go a little bit up more. Right. So, of course, we start from 0, 10, 20, 30. And of course, this is 35. So we're somewhere 36, 37 degrees thereabout. 37 degrees. So I want you to make note of both information because we're going to use a different method by calculation to determine that what the graph gave us was accurate as well. All right. So remember now, the length of our magnitude is 5. Let's write that down somewhere. So the length of the magnitude of our vector is, let's get back to our color. Okay. So the magnitude of the vector, or magnitude of vector AB is equal to 5 centimeters, and the direction of the vector is approximately 37 degrees. All right. Now, I want to note something though, before we go any further. In terms of the direction of the vector, note you can also complete a triangle right here. Good. And note, kind of erase this. Let's see if we can reduce this. We can move this over here and see if we can recreate back our vector here. All right, good. So let's recap a bit before we go any further. We were saying that the magnitude vector is formed, the direction of the vector actually is formed between the vector itself and the horizontal line. Now, if you did trigonometry, you'd have observed that we can use the opposite length, which would have been our y-axis information, as you can see, and our horizontal length should have been our x-axis information to help us to determine which trig ratio to use. And commonly you use the tan ratio to find the direction of a vector. You commonly use the tan ratio to find the direction of a vector, commonly used. All right, so now I'm going to show you how we can find the displacement vector without using the graph. Let's get that out of the way quickly. Right, so here it is. How is that done? All right, so we're going to be finding the vector AB. Now, we have to use two position vectors to find vector AB. So let's write that down, AB. And the two position vectors obviously is OA plus OB. Why those two? Because of the letters A, OA, B, OB. You may want to ask the question, and sir, what if it was CD? Which two position vectors would I need to use? Now, if it was CD, then you would have to use the position vectors what? OC and OD. So you use the letters given in the displacement vector to determine which two position vectors that you'll use to solve or to find the displacement vector asked to express. Now, in order to come up with AB, though, we have to rewrite vector OA. And so, vector OA, the AB then, will now be equal to AO plus OB. That is what it's going to be. Now, if you notice, we reversed. We started off with O as our starting point and end with A as our ending point. But for us to rewrite it, we have to now go the opposite direction, which now becomes A, O. Therefore, whatever vector OA was would have to now become negative. Okay, would have to now become what? Negative. So then, vector OA was 3, 5 before. Let's write that. Vector OA was 3, 5. So now it's going to become negative 3 and negative 5. Now we're going to add that now to our vector OB, which is 7, 8. So in this case now, we're seeing that you have to know integers or know how to use a number line. Good, when adding negative and positive numbers. So negative 3 plus 7 will give us positive what? 4. Negative 5 plus 8 give us what? Positive 3. And so we have vector AB using the calculation of the graph. And here it is. Same thing. So the graph was right. Calculation is also right. So now we're going to calculate now to find our displacement, the magnitude of the displacement vector without using the graph. For those who are just joining me on this session, of course, I'm your student, Ronnie Bernard, your presenter for this evening. And I ask that if it's the first time, viewing this channel, I ask that you subscribe if you have not yet subscribed, because we're not going to give you a schedule this time. We will just appear. If you want to know when we appear, guess what? You got to subscribe so you can get your notification so you know when to join us live on our YouTube channel. And of course, if you're viewing now You can ask questions. Feel free to ask a question. Feel free to answer a question using our chat feature. Now, of course, if you have a friend or family is doing the exam, feel free to share the link. Tell them about it. And of course, you must click that like button if you like this session. Go ahead now and click the like button. If you like the session, go ahead and click the like button. If you're viewing this after the live session, leave us a comment. Leave us a comment. If you want us, okay. I'm seeing my dear friend Young DK out. Good night, sir. Good night to you. Thank you very much for always supporting our channel. And I'm asking that you can share this link with your friends out there and your family. And I know you're from the Caribbean. And I'm saying special thanks to you. And I must say to you, Young DKO, that we have registered with us now students from other Caribbean countries like Grenada. And one of these evening, I will invite her to come online, to come on one of our live sessions. She's a bit of a shy person, but we'll get her on the live one of these nights. Of course, we also have another student from outside of Grenada, outside of Jamaica. That is, she is from um, Cayman, and we have another one in Antigua. So we have students have been coming from joining CDP Language Services as a registered students outside of Jamaica from the Caribbean. And of course, you have our um, person who's always watching, young DK out. You always been watching and always been supporting CDP Language Services. And every night, every day, every week, every hour, every year, we welcome your support. Okay, let us continue with, so we just looked at how we could find the displacement vector without using the graph. So now we're going to look at how we can find the magnitude of the vector without using the graph. We looked at how to find the magnitude of the vector by using the graph. So now we're going to look at how to find the magnitude of the vector without using the graph. Let's see how that is done. Are you ready? I know you are ready. Let's go. So the first thing, before we can find the magnitude of the vector, we first would have to know what the vector is. So the magnitude of the displacement vector AB, we're going to find now. But of course, the vector is 4, 3. So now how do we then now find the magnitude of this vector? Now you'll use to find the magnitude of the vector, we can use the distance formula. And that's what we're going to use this evening to find the magnitude of the vector. Now let us write the distance formula. And the distance formula goes like this: square root, square the x-axis itself, and they add that to the square y-axis itself. Good. All right. Then now we're going to work out what's under the square root sign first before we find. So the last step really is to square the sum of the square of, the last step is to find the square root of the sum of the square of the axis plus the square of the y-axis, y value, right? So x is to 4 square plus 3 square. So 4 plus 4 squared is 16. and 3 squared is 9. 16 plus 9 will give us 25. Good. So now our last step now is to find the square root of 25. And that will give us the magnitude of our vector, which is 5. So when we used the ruler before, it gave us 5. The calculation, it also gave us 5. Now, one important information, how to know if they're asking you to find the vector of the matrix. It's simple. You have 2 parallel lines, and then the letters in between. A, B. That's how we know that they are asking us to find the magnitude of the vector. All right? Hope you got that. All right. So we used the graph earlier to find the displacement vector. We use the calculations also to find the displacement vector. We use the graph to find the magnitude of the vector using our ruler. And of course, we use the calculation method, the vector method, to find the magnitude of the same vector. So you're learning both methods in this session. All right. So now we're going to look at how do we find the direction of the vector using calculations without using the graph. All right, let's look at how that is done now. All right, so we're now going to find the direction of the vector. Now, of course, as I told you before, the first digit, which is the x-axis, good, and of course, which is the 3, which is the y-axis. Now, if you weren't given a graph in the exam and you're asked to find the direction, just simple sketch your triangle. This is A, this is B, and you know that this value here is the x, so you put it right here. This value here is this value here is the y, there's 3, and the first one is the x1, which is 4. And then you have to find the angle right here. So you are given the adjacent and the opposite. And we know that that is tan theta. So we're going to use a trig ratio. Tan theta is equal to opposites over adjacent. Good. So let's go ahead and do that. Now we know that the opposite length is 3, and we know that the adjacent is 4. So we're now going to divide 3 by 4, and that is going to give us what? 0.75. Now 0.75 is not, I repeat, 0.75 is not the direction. But to find the angle now, we're going to have to find the tan inverse of 0.75. So the tan inverse, let's write that. Let's come down here. The tan inverse, and this is where you use a calculator now. The tan inverse of 0.75 is equal to what? You can pause and give you a moment Use a calculator and figure that out. We find the tan inverse of 0.5. What is the tan inverse of 0.75? You go ahead now and tell me what that is. The tan inverse of 0.75. We're winding down gradually. We're winding down now. We're winding down now gradually. So winding down gradually, right? So grab your calculators and you're going to type in to find the tan inverse of 0.75. For some calculators, you have to type in well, I'm going to use my calculator now. And go for my calculator now. And I hope you're doing the same for yours. And if you want to go ahead and give us the answer, you can give us the answer in the chat. So I'm going to look for my tan inverse now. So we're going to type in the inverse of tan. We want a second function. Let's see, second function. So I have tan inverse. So let's clear all of that. So I hope you're doing the same, trying to find tan inverse. And the tan inverse of 0.75. All right. Now, for some calculators, you have to then type in 0.75 first. Type in 0.75 first, 0.75, and then you click on the second function, the tan inverse. And your answer is, your calculator would have shown you 36.86. And of course, you can round it off to the nearest whole number, which will be 37 degrees. And you'll see exactly that how I showed you on the graph, it was using the protractor, it was indeed 37 degrees. So we have used the graph and calculations to show you how to find displacement vector, magnitude of a vector, and of course, the direction of a vector. All right. Now, you can join us on CDP Labs Edu Services or register for CDP Labs Edu Services by going to our website, right? And fill out the registration form to become a student so you can benefit much better from the classes. And of course, we practice the flipped classroom approach to teaching, one of the world-renowned method with best practices. We practice best practices at the CDP Labs Services, an online registered institute, right? So nothing to fear. It's all to gain and be successful in your endeavors. We are the #1 examination preparation agents. Ask our past students and they'll tell you. All right. So now we're going to go now into at least, we're going to look at the vector question for the June 22, May-June 2022 CXE exam pass paper. Are you ready for it? If you're ready, say ready, man. Say ready. If you're ready, say ready. All right, let's go. All right, so I'm going to go straight to that right now. All right, so here is the vector question that came in the May 2022, June 2022 exam. Now, the question says, in the diagram below, 0 is the origin. So of course, on the graph, this would be the point OO, or 0, 0 rather. Then we have OX, and you see OX, you can tell me what type of vector is OX? We just discussed it. It is the what? Position vector. And of course, OY is another position vector. Good? Now, so OX is equal to U, and OY is equal to the letter Y. Now, OX and OY are extended so that X and Y are the midpoints of OA and OB respectively. Now, the word midpoint is a very important word. But pay attention to these key things. Let's put on the spotlight. So the word midpoint is a key word that you must pay attention to. Now, in our classes, I normally ask my students, what do they understand from the word midpoint? Some persons would say middle. Some persons would say half. And those who said half will work with the numerical meaning, which is half, indeed. Something is divisible by 2. Good? All right. Now, let's see now what we're asked to do with this question. So we're asked to express Bx in terms of U and V. Now, my big question to you is this. What is Bx? What type of vector is Bx? Now, Bx is a displacement vector. Remember we looked at it earlier? Bx is a displacement vector. Now, I must express it in terms of U and V. What does this mean? It means that the answer must have U and V in it. Now, however, we still have to use the 2 position vectors to find Bx. Remember what I told you? So let's write. Now, so Bx is equal to, of course, OB plus OX. Good? Remember I told you, you have to use the letters. So B, OB, X, OX. Hope you got that. Now, so let's move on from there. Now, OB, vector OB is an extended length of OU. So remember that Y is a midpoint or is at half of OB. That means OY is half of OB. So if OY is half of OB, that means that OB is twice OY. So if OY is V, then OB must be 2V. Good? Yes, that's how we reason it out. So this now becomes negative 2V because we write it as BO. Let me do that first before I rush into that. So Bx then is now equal to what? BO plus OX. And we go up here So BO is negative 2V, and of course, OX is U. And that's our answer. You have expressed it in what? V and U. That's the answer. 1 mark. 1 mark. That is the answer. So if you like the session, I ask that you will click on the like button. And I see 3 persons liking it so far. Thank you for clicking on the like button. All right. And if others are viewing, click on the like button. If you have not yet subscribed, subscribe now, so you know when we continue this lesson on vectors. All right. We're almost through with our first session. And of course, we've gone 1 hour, and we are not going to go for too long tonight. So let's move on to our other question. Part 2 of this question. Now, they're asked now to says, given that YA and BX intersect at M and BM is equal to 2MX, express BM in terms of U and V. Now we're going to pause right here and check us tomorrow evening if you wish to see how this part, A and B, is done. Check us tomorrow where we go part 2 of this lesson. And then, of course, we have more possible questions to look at. 2019 and vectors. Now, I must say to you once again that we'll continue to go live streaming with our mathematics course. And we ask that you subscribe now, that you'll be able to see how the multiple choice questions are done. So, of course, welcome to CDP Labs Services. Thank you very much for joining us live in this session. I pray that you will be with us for our next session where we look at the 2022 multiple choice questions. Of course, we'll continue though with the vector questions to complete the concepts on vectors, collinearity, and so forth. And we look at some other vector questions. Then we'll go into our multiple choice questions. Now, if you want to get access to how to do the paper 2 questions, you have to be a registered student of CDP Labs Edu Services. So, from me to you, it is good night. Once again, from Mr. Bernard here at CDP Labs Edu Services, situated in Kingston, Jamaica. I hope that you were refreshed and that you enjoyed this session. And of course, I sincerely hope that you were blessed with this session and that you would have benefited a whole lot from our lesson today. Stay tuned to CDP Labs Edu Services.